Alright, we're going to look at part 2 of section 1. So we finished up with these 3 problems, and we're going to look at this next problem here, where you have absolute value of x plus 4 equals x plus 4. So how do I solve problems like this? Not necessarily this one in particular, but these problems where we have multiple absolute values in our problems, and we have to figure out what to do. So let's start with the first one. So we have the absolute value of x plus 4 equals x plus 4. If I treat it the same way I did the other, I'm going to set it equal to the positive, and I'm going to set it equal to the negative. And then I'm going to solve the problem. So I'm going to subtract x and I get 0, and I subtract 4 and I get 0. So 0 equals 0 means all real numbers are my solutions. And in this one, I have x plus 4 equals negative x plus 4, and I distribute it. And I end up with 2x equals negative 8, x equals negative 4. So when I combine those two together, I find out that my solution is going to be all the values from negative 4 to infinity. So when I go to a graphing calculator and I want to look at that on my calculator, I'm going to put in here the x plus 4, and in this equation I'm just going to put x plus 4. And when I graph this on my graphing calculator, there's my absolute value and there's my line. And so you'll notice on my graphing calculator that from this point, negative 4, all the way up here, it overlaps. And that's what we're looking for when we're looking for the solutions, is where is there an overlap. Okay, so let's look at the next one. So you can write your solution either this way or this way right now. We will work on writing our solutions always in this format. So this next one, I've got the absolute value of 3x minus 1 and absolute value of x plus 5. So we're going to be using a concept that we call breakpoints. And breakpoints is supposed to help us a little bit, number one, to eliminate a little bit of our work, but it also creates some more. So to find our breakpoints, we're going to take each of the absolute values and solve for 0. So I'm taking the 3x minus 1 is equal to 0, and I'm taking the x plus 5 and equal to 0. And I get 1/3 and negative 5. So I put that on a number line. Here's my 1/3, here's negative 5. And then I think about numbers that are surrounding those. So negative 6 is less than negative 5, 0 is somewhere in between here, and 2 is somewhere over here. And I just randomly picked numbers. I didn't want to pick numbers that were too big or too small to make it work right. When I put that negative 6, I'm going to test these values. When I put that negative 6 into the absolute value part, I get 3 times negative 6 minus 1 is negative 19. That's a negative. And then I get negative 6 plus 5 is negative 1. That's a negative. So all the things over here are going to end up being negative and negative. Then I test the 0, and I do 3 times 0 minus 1 is negative 1, so that's negative. And then I do 0 plus 5 is 5, that's positive. So all of the things in this area, I'm going to do the opposite and then positive. And then I test the 2, and I get positive 5 and positive 7, so positive and positive. All the things over here are positive. So what does that mean? So when I take this solution, this problem, in this area, I'm going to put a negative on the first term and a negative on the second term. And I'm going to then solve the problem. So remember, I'm doing the opposite, not just doing the negative. So distributing my negative sign, I get negative 3x minus 1, negative x minus 5. Combining like terms, I get x equals 3. So in this area right here, I got a 3. But 3 does not exist here. This is negative 5, negative 4, negative 6, negative 7, negative 8, negative 9 on a number line. 3 doesn't exist. So that's not a solution. It's what we call extraneous. Okay? Then I check it with the negative and positive. So I put a negative on the first term and a positive on the second term. I go through my solution, I get negative 1. Well, between here and here, it's negative 1. Negative 1 does exist in this area, so it is good. So we're going to keep that negative 1 as a solution. And then my last chance is to take them both positive. Here's my positive case over here. So I just take the first term, take the second term, I solve it, I get x equals 3. So from here to here is 3, and 3 does exist in this area. So 3 is a good solution. So the two solutions to my problem are negative 1 and positive 3. Now again, if we look at our graph, it is a way to check ourselves. You're not always going to have a calculator though, keep that in mind. So we have 3x minus 1, and then in our other problem, we're going to do the absolute value of x plus 5. And when I graph these two, there's my first absolute value, there's my second absolute value. And if you look at these intersection points, right there is about negative 1, and this intersection point right here is about 3. So our two intersection points are negative 1 and 3. So that works. So that's our solution for that one. So again, the solution for this problem is negative 1 and 3. Alright, let's do the next one. So again, our breakpoints are going to be 3 and negative 2/3. And I got that from this term and this term. So I put it in my number line. Here's my negative 2/3, and here's my 3. A number over here that I could use is negative 1. A number in here is 0, and a number in here is 4. And again, I'm just making those numbers up. When I put negative 1 in here, I get a negative number. Negative 1 minus 3 is negative 4, so that's negative. And when I put a negative 1 in here, I get negative 3 plus 2, so that's negative, so I get negative and negative. When I put 0 in, I get a negative here, and I get a positive here. Negative and positive. When I put 4 in, I get a positive here and a positive here, so that's positive and positive. So again, I'm going to solve it with negative and negative. Then I'm going to solve it with negative and positive, meaning I don't change it. And then I'm going to put it positive and positive. So when I do negative, negative, I get negative 3. Negative 3 does exist in this area. So that means negative 3 is a good solution. 1/2. 1/2 is not, 1/2 is in this range from negative 2/3 to 3, so it's a good solution. My last solution comes out to be negative 2, but negative 2 is not in this area, so negative 2 is not in that range, so it's extraneous. So the two solutions that I get are negative 3 and 1/2. And you can try and put that in your calculator and check it and see what you get. So again, negative 3 and 1/2 are the solutions for this one. Let's look at our next one. So again, our breakpoints are negative 1 and negative 3. So we put the negative 1 and negative 3 in here. We're going to use the points negative 4, negative 2, and 0. Negative 4 would mean this would be negative, negative. Negative 2 would be negative, positive. And 0 would be positive, positive. So we're going to go through and solve our equation with those breakpoints. So when we do negative, negative, remember we're putting a negative in front of here, but there's already a negative. So I end up putting negative, negative, opposite of this, and the 4. And that ends up being positive, so it doesn't change anything. And I end up with 2 equals 4, because the two x's cancel out. Well, that's not true, so there's no solution in there. Okay? Then I check this one. This one's going to be negative, positive, which means I'm going to make this negative, the opposite. I'm going to leave this alone. So it was already negative, so I don't change it. So I end up with this, which is negative 2x. This is negative 4. And when I take that negative 4 and what did I do wrong? Okay, so I have negative x minus 1, I have negative x minus 3, and I have 4. I end up with negative 2x. I end up with negative 4. I did something wrong here. I end up with negative 4 equals 4, and then I'm going to add that 4 to both sides, so this ends up being 8. Negative 2x equals 8, and then x equals negative 4. So the problem is negative 4 is not in this range between negative 3 and negative 1. So that's an extraneous solution. Okay, sorry, I had a little mistake there. And then I have positive, positive, which means I don't change this one. Combine it together, and again I get no solution. So every time I checked it, I got no solution. So this problem has no solution. So what is that going to look like on my calculator? So we're going to put that in, and I'm going to put it in exactly like it is on the paper. So this is going to be x plus 1, and then minus x plus 3, and then for my second equation I'm going to put the 4, and I'm going to graph it. So there's my two absolute values, there's that. And you'll notice that those two lines, this one looks a little weird, but those two lines never cross, so there's no solution to that problem. Alright, our last one is the same type of problem. So our breakpoints are 0 and 0 and positive 2. And so we're going to check negative 1, 1, and 3. So I get negative, negative, and positive, positive. But this time it's positive, negative. So notice what happens. So on this problem, this is the first one, we had positive, the negative, negative, positive, positive, but we had negative and positive. On this one, we had negative, negative, positive, positive. We had negative and positive. On this one, same thing, but this one, we have positive and negative. So sometimes it can change a little bit. So we're going to do negative, negative, and this comes out to be 0. 0 is not really in this range, but 0 is right here. It's one of the breakpoints, okay? And then we solve this one with the positive and negative, and we get 2 equals 2, which is all real numbers. And then we solve this one with positive and positive, and we end up with x equals 2, so 2 is the breakpoint again. So what ends up happening is that only the values between 0 and 2, including 0 and 2, are my solutions. So that's what my answer is. My answer is only the values between 0 and 2. Okay, so let's look at these last two word problems real quickly. The first one is the gas mileage in miles per gallon obtained during a long trip is given with this formula. S is the speed in the automobile after in miles per hour, and it has to be some number between 40 and 70 because you can't speed. At what constant speed can Kate drive to obtain exactly 22 miles per gallon? So what we're looking at is we want this equation that you see here with 22 here. So we're going to treat it like we did the first equations. We're going to move the 25, then we're going to move the 1/2, and we get this. And then we're going to solve it with two different equations with 6 and negative 6. So I get 61 and 49. So Kate has to drive between either 61 miles per hour or 49 miles per hour to get that gas mileage. Okay, and the last one, it says the percent of a file that remains to be downloaded using a dial-up internet for certain modems, I'm sure you don't know what dial-up internet is, has this particular equation. N is the size of the file in bytes, and T is the number of seconds. So we're going to fill in that information, and we're going to just solve this. This doesn't involve absolute values. And we get 892.85 seconds, but we want minutes, so that's 15 minutes.